everyone! Welcome to our channel. Today we will be doing our laboratory exercise number 7, LCD interfacing. Without further ado, let's get started.
So let's proceed to our program 1, the Peace, Love, and Code. So our task for this program is to create and design a display showing the graphics, the word peace, love, and code, as well as their corresponding symbol. We need to draw the schematic using Tinkercad or Fitting software or whatever software is available for you to use. And we need to write the code that will show the graphics and run the program and verify that it works properly. So without further ado, let's proceed to our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board, the breadboard, the LCD 16:2 display, as well as the potentiometer. So we have here a potentiometer. This is for VO or the VEE contrast adjustment. So it says that the best way is to use a variable resistor such as potentiometer. The output of the potentiometer is connected to this pin, and rotating the potentiometer knob from left or to the right will adjust the LCD contrast. So to the left, we'll adjust the contrast to nearly gone, and to the right, we'll adjust the contrast to its brightest. So let's take a look at our program code. So as you can see, we have here the hashtag include liquid crystal.h. So this includes the liquid crystal library to control the LCD. And we have here the initialization of the LCD, the liquid crystal LCD, which creates an LCD object and sets the pins used to interface with the LCD. We have the 12 to 2. And this 12 to 2 is the pins that are connected to the RS, the enable, the D4, D5, D6, and D7. So we have here the custom characters. So defining these custom characters, we have the byte piece left, byte piece mid, byte piece right. So this defines the byte arrays for the custom characters. The left, middle, right, parts of a peace sign, and the left, right, and the right halves of the heart. So we have here the setup function. So this setup function initializes the LCD. We have the LCD begin 16:2. So this corresponds to the 16 columns and 2 rows. We create the custom characters in the LCD memory here. So we set the cursor position to 1 and 0 and writes the custom characters and strings to the LCD. So we have the display, the peace sign here at position 1 and 0. We display the heart position at 7, 0. We display the greater than and less than at 12 and 0. And we display the text peace, love, code at the start of the second row, 0, 1. And we have here an empty void loop function because we don't have a continuous operation in this program. So let's start the simulation to see if the program runs or functions properly. So since we've said before that the potentiometer, when knobbed or rotated to the left, we don't have a contrast display. And let's try shifting it to the right or rotating it to the right to see if the contrast will adjust and will show the peace, love, and code. And there you go. We have the peace, love, and code as well as their corresponding symbols. And that is all for our program 1, entitled Peace, Love, and Code. So let's proceed to our program 2, Marquee Message. So we need to create and design a message marquee system. The program will be controlled by 2 LDR or light dependent resistors in displaying the 2 marquee messages. That is, if the left LDR has sensed, it will display the marking message from left to right direction. Welcome to the PUP CPE department. Otherwise, it will display the marking message Goodbye, see you again next time from left to right direction. And we need to draw the schematic as well using Tinkercad or fitting software and run the program and verify that it works properly. So without further ado, let's take a look at our Tinkercad. So as you can see, we almost have the same configurations and components as per the program 1 and program 2. So the only difference is here is that we added LDR, the two LDR and two resistor, which will function as a marking message. So the marking message will depend on this LDR, the LDR1 and the LDR2. So let's take a look at our program code. So as just like before, we have here the include liquid crystal library, and we have the initialization of the library with the numbers of the interface pins. So we have here the const int left LDR and right LDR. So this specifies the analog pins for the left and the right LDR. We have the A0 and A1. The A0 and A1. And we also have here the const int threshold, which defines the light threshold values. So this determines if the light levels are high enough to trigger the action. And we also have the const char message 1 and message 2, which is the welcome to the CPE, PPCP department, and goodbye to see you again next time. And we have here the function of the scroll message. So we have here we have here the char buffer. So this char buffer creates a buffer of 17 characters, 16 characters for the display and 1 for the null terminator. And then we fill the buffer with spaces initially, which is this one. And we shift the message across the buffer and prints it to the LCD, creating a scrolling effect. And we delay the shifting by 300 milliseconds or 0.3 seconds. So in our void setup, we have the LCD begin, which initializes the LCD with 16 columns and 2 rows. We have the LCD.clear, which clears the LCD screen. And we have here the void loop, the loop function. So this continuously reads the analog values from left and right LDR. And displays the scroll messages, message 1, and the scroll messages, message 2. And clears the LCD if neither LDR values exceed the threshold. So let's start the simulation to see if we're really accomplishing our objective. So initially, the LCD should be blank because we haven't put the locks yet of the LDR, both LDR. So let's try first the LDR1, which this should display the welcome to the PUP CPE department. And there you go. As you can see, we shifted the locks of the LDR, or it detects the light. So it shows the welcome to the PUP CPE department. Now if I didn't do anything, it should display it again, and there you go. Now let's try shifting the locks for the LDR to the LDR2 to display the message 2, which is the goodbye one. So there you go. It displays the goodbye, see you again next time message. So with that, we verify that the program runs properly. And we have here the potentiometer, which functions just like the in program 1. So if we shift it, we rotate this to the left, the contrast of the LCD screen display will begin. And just like that. So that is all for our program 2, the marquee message. Now let's proceed to our program 3. a decimal calculator. So we need to create and design a decimal calculator that can perform the following mathematical operations such as addition, subtraction, multiplication, and division. The mathematical expression formed from typing it via the keypad is being displayed over the LCD as well as the output of the said mathematical expression. So we need to draw the schematic using Tinkercad or Phrasing software and run the program and verify that it works properly. So without further ado, let's take a look at our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board, the breadboard, the LCD 16x2 display, and the addition of the keypad 4x4. So let's take a look at our program code. So like before, we have the liquid crystal here, the library, and now the addition of the include keypad. So this includes the keypad library, the interface with obviously the keypad. And we initializes the LCD again, which creates an LCD object. And we have here the const byte rows, const byte calls, and the char keys rows and columns. So this defines the layout of the keypad and specifies the pins used to interface with the keypads, which are as is. We have the 4 rows and 4 columns. And we have the keypad here. So this creates a keypad object to handle the input from the keypad. We have here the string expression and the float result 0.0. So this defines the variable to store the mathematical expression and the result. We have the setup function, the begin and the clear again of the LCD. We have the loop function. So in this loop function, we continuously check for the key presses. So if key is equal to C, so which this also clears the LCD expression if the C is pressed. If C is pressed, clears the expression and the LCD. And we evaluate the expression and displays the result if equals is pressed. So we evaluate the expression and then displays the result on the LCD. And we add the press key to the expression and displays it to the LCD as I mentioned. So we have here the float or evaluate expression. So this parses the mathematical expression to find the operator and the operand. This performs the arithmetic operation based on the operator and returns the result. So we find the operator and split the operands. We have the plus, minus, multiply, and the divide. And then we handle the division by 0 by returning to 0 in such cases. So if case plus returns operand 1 plus operand 2, if case minus returns operand 1 minus operand 2, multiply, divide, and then if obviously we can divide by 0. So if the value is not 0, operand 1 and operand 2, which handles the divisions by 0. Then we return 0 if the expression is invalid. If the inputted for the division is by 0. So let's try simulating the program to see if it functions properly. Start simulation. Okay, so let's try the addition first. So remember, A will correspond to plus, B minus, C multiply, and D for the divide. We have here the asterisk for clear, and we have here the pound or the hash sign for equals. Let's try 1. So this displays in the LCD screen plus 1. So this should display 2. So let's press hashtag for equals. And there you go. And then let's clear. Let's try other number. 4 plus 6 is 10. So let's try subtracting. 5 minus 2 is 3. 9 minus 6. Oops, 96. 6 minus 6 is equal to 0. And let's try multiplication. We have 5 times 9. This should display 45. Then there you go, 45. And then let's try division. 9 divided by 3 is equal to 3. And there you go. As you can see, it functions properly. That is all for our program 3. So let's proceed to our program 4, password-driven piezo buzzer. So our objective for this program is first to design the circuit. We need to create a circuit schematic using Tinkercad or Fitting software that includes an Arduino, a keypad, a piezo buzzer, and multiple LEDs arranged to run from left to right. We need to implement a password input. Write an Arduino code to prompt the user to enter a password through the keypad. And we have a password validation. We need to validate the entered password against a predefined correct password. We need to allow up to 3 attempts for entering the correct password. So if the password is correct, buzz a correct musical tone using the piezo buzzer, and light a sequence of LEDs running from left to right to indicate the success. Otherwise, buzz a different tone using the piezo buzzer, display an incorrect LED pattern to indicate the failure, and prompt the user to retry entering the correct password. So to handle the incorrect attempts, after 3 incorrect attempts, display the keypad to prevent further password entries, and display the specific prompts such as enter your name, enter your password, access denied, and attempt already based on the password if it is inputted correct or incorrectly, and use a blinking effect for visual prompts. So for user interaction, we need to provide a user-friendly interface with clear prompts and visual feedback using LEDs and buzzer tones. And for testing and validation, we need to ensure the program functions correctly on the Arduino hardware. And verify that all prompts, LED animation, and buzzer tones aligns with the expected behavior. So without further ado, let's proceed to our Tinkercad. So as you can see, we've already placed the components. We have the keypad, the Arduino Uno board, the breadboard, the potentiometer, the buzzer, the LED 16x2 display. And we have the LEDs here. So let's take a look at our program code. So as you can see, we've already defined the library again. The library for the LCD and the library for the keypad. And we already initialized the LCD library with the numbers of the interface pins. And we define the keypad layout. We have the 4 row and 4 columns again, just like before. And we have the keypad, the byte row pins, just like before again. And we have here the addition of the const int buzzer pin. So this is specify the pin for the buzzer, and the const int LED is a pin for the array of pins for the LEDs, which are using the analog 0 pin, and for the LEDs we have the analog 1 to analog 5 pins. So we have here the const string correct password. So this sets the password, initializes variables for user inputs, and defines the maximum number of attempts allowed, which is maximum attempts is 3. We have the setup function here. So this initializes the LCD 16 columns and 2 rows. We have the resets the LED pins as outputs, and then turns them off low, and sets the buzzer pins as output, and displays a welcome message. LCD clear, and then LCD.print enter your name. We have the void loop here. So this continuously checks if the user's name is entered. If not, so if username, get username. If not, it calls the get username. And we prompt the user to enter a password, enter password, and checks the entered password and display messages accordingly. So we have here we grants access and welcomes if the user password is correct. Otherwise, denies the access denied, and increments the attempt counter if the password is incorrect. Attempts and increment max attempts. And as mentioned before, we only have 3 attempts. And locks out the user, disables the keypad after the maximum number of attempts is reached. We have the get username function. So this prompts the user to enter their name using the keypad and stores the name entered by the user. We have the string get password. So this prompts the user to enter their password using the keypad and mask the input with asterisk on the LCD. We have the buzz correct function. So this sounds a buzzer with a specific tone indicating correct password input and displays access granted if the password inputted is correct. And we have the buzz incorrect function sounds a password with a specific tone indicating incorrect password input. And we have the void running LED function. This lights up LEDs in sequence to indicate success or failure. We write LEDs from left to right. So, and lastly, we have the void disable keypad. So this disables the keypad by entering an infinite loop after maximum attempts, 3 attempts, are reached or successful login. So let's try simulating the program to check if it functions properly or if we're accomplishing the objectives properly. But before that, I think I skipped over the password. So our password is 12345. So let's remember that. And let's go to start simulation. So it displays the enter your name as mentioned in the in our code. So let's try entering our name as 7, 8, and 9. And then we'll click the hash to break or to enter the key. And then we enter the password 12345. And there you go, access granted. Welcome 789, which is the name that we inputted. And if you've noticed, it displays a sequence of the LEDs and the buzz indicating that we access that access is granted. Now let's try resetting the button, the function rather, or the Arduino. And let's try entering our name again as 789, but for the second time, I will be inputting our incorrect password 3 times. Access denied, 1 attempt. Let's try another one. Access denied, 2 attempts. And for the third time, access denied 3 attempts. And then it says max attempts, which prompts us that the keypad is no longer functioning properly because we are locked out of the access as we've reached 3 attempts already. So that is all for our program 4. So let's proceed to our program 5, a DIY LCD keypad video game. So we need to create our own LCD keypad video game, and we can also include a tone rendition as we play the game. So we need to draw a schematic using the Tinkercad or Fusion software, and we need to run the program and verify that it works properly. So in this program 5, we'll be creating our own video game using the LCD keypad. So without further ado, let's proceed to our Tinkercad. So as you can see, we've already placed the component, and if you've noticed, everything is just the same as with the previous program, the program 4. The only difference here would be the program code. So let's proceed to our program code. So as you can see, almost everything is just the same as the previous program or the program 4. Because as mentioned before, we have the same configurations here. And obviously the same initialization for the codes. Initialization codes because we're using just the same components for the keypad, the LCD display, the Arduino, the potentiometer, the LEDs, buzzers, etc. So let's skip that part and let's proceed here to the in target number. So this in target number is basically the target number to guess, because our game is a guessing game. So we have a number to guess from 1 to 100, and it will say too high or too low depending on your inputted number. Like for instance, if the number is 55 and you inputted 45, it will say too low because the number that you've guessed is lower than the target number. And if you've guessed 66, which is higher, then it will say too high. And our maximum attempt, we have 10 int max attempts, and the int attempts, this will track the number of attempts. We have the void setup, we have the LCD begin, which sets up the LCD number of 16 columns and 2 rows. We initializes the LED pins here. The pin mode, we set the LED pins as output so that it displays the sequence. And we have the pin mode buzzer pins. So this, just like the LED, we set the buzzer as output to display or to hear the sound of the buzzer. Now we have here the random seed and the target. We have the random seed which generates as the random number which generates the random number. So the target number that generated will only be from the range of 1 to 100. So it will be random when you start the simulation. And we displays the initial message and place the startup sequence. So LCD clear, we clears the LCD and print the guess the number. And we have a delay of 2 seconds or 2000 milliseconds. And then clears. And then it will say LCD print 1 to 100. So prompting us to print our guess number depending on our target number. And then we have the running LED sequence at the start. Now we have here the void loop. So in our void loop, so we have here the numeric keys. If a number key is pressed, add it to the guess, and then guess plus is equal to key, and then it will press, and the LCD will display print guess. And when we click the pound or the hash, then it will enter the guessing number and it will check if our guess number is equal to our target number. And if correct, sets the cursor 01, and then we will stop the game because we've guessed the correct number. Otherwise, it will prompt attempts and the number of attempts we've already done, which this will depends on the attempt we've done, and it will say too high or too low depending on the number that we've inputted and the target number, and it will buzz incorrect. And then it will clear the guess and then print again, prompting us to print again 1 to 100 number depending on the target number again. Obviously we're guessing the target number, and then it will print again the number of attempts if we inputted again the incorrect number. If attempt is greater than or equal to the max attempt, which is 10, it will print game over, and it will show the number or the target number, and then it stops the game. Else, if key is pressed, clear the guess, and then prompting us again to print 1 to 100 number to guess the target number. And we have here the utility functions. We have the buzz correct and buzz incorrect, which emits the correct tone or the incorrect tone on the buzzer. And we have the running LED sequence, which controls the LED sequence for startup and success or failure indications. So let's try simulating the program to see if we're accomplishing the task or the objectives properly. So start simulation. So as you can see, it displays the LED, guess the number, and then clears it, and then it displays 1 to 100. So we need to guess 1 to 100. So let's start by guessing number 44. So it says too low, and then the attempts is 1 because we inputted an incorrect number. So if 44 is too low, let's try 55. Too low again. So let's try, so it says 2 attempts. So let's try 66. Too low again. So let's try 77. We have 3 attempts already. And, oh, there you go. We have a correct. Attempts we've done is only 4. So let's try resetting Arduino and try again. So let's try 99. And there you go, it says too high because previously we're just inputting something like the number is too low. Now we're saying too high, and the number correct is 77. Now let's try inputting an incorrect number 10 times. Let's see what will happen. Too low, attempt 1. Too low, attempt 2. Too low, attempt 3. Too low, attempt 4. Too low, attempt 5. So we just want to see what will happen if we inputted incorrect guess for 10 times. Now we have attempt 8, attempt 9, and then for our final attempt, game over. The number is 77. So, as mentioned before, if our guessing attempt is greater than or equal to the max number attempts, it will display game over and it will show the target number. And that is all for our program 5. Thank you.